Hi, folks. Before we do the programming for our cone, I want to address a problem that you're going to run into. A cone might be given the radius and the height, but missing the slant height. This L is called the slant height, and it's different than the height of the cone. It's the distance along the kind of the side of the cone here. The thing about it is that it is a right triangle, and so we can find the missing part. If we know the radius is 3 and the height is 4, then we can use a squared plus b squared equals c squared, or in other words, the Pythagorean theorem. In this particular case, the two legs are 3 and 4. And hopefully you know that the special right triangle gives us 3, 4, 5. And so we know that the length is, or the slant height is 5. But of course, it's a good idea to go ahead and write it down. So we've got 3 squared plus 4 squared is equal to L squared. And in this case, 3 squared is 9 plus 16 is equal to L squared. And this is 25. The last step is to take the square root of both sides. And of course, the square root of L squared is going to give you L, and that's going to be equal to 5. This is a special case. Most of the time you're going to get, an estimated decimal with a radical expression in it. So this is if you know the radius and the height and you're missing the slant height. The reason you need to know that is to be able to find the surface area. With the radius and the height, you can find the volume of a cone, but you can't find the surface area. Suppose in the second part that they tell you what the slant height is 13 and the radius is 5. And again, this is a special right triangle. Now, in this particular case, you have to be careful. My legs are 5 and h, and I know the slant height, which is the hypotenuse. So I'm going to write it like this: 5 squared plus the h squared is equal to 13 squared. And you should know what this is because this is a special right triangle. But I'm going to go ahead and work it out. 5 squared is 25 plus h squared is equal to 169. And we're going to subtract the 25 from both sides. And that gives us h squared is equal to 169 minus 25 is 144. And we're going to take the square root, and h is equal to 12, of course. And a lot of you already knew that. 5, 12, 13 is a special right triangle. Again, that allows us to find the volume. If we only wanted the surface area, all we need is the slant height and the radius. The last one is if I know the height and the slant height, and I'm missing the radius, then again, I do the same type of thing. L happens to be 10, the slant height is 10, the height is 8, and we're missing the radius. So r squared plus the 8 squared is equal to the 10 squared. And hopefully you recognize this as a 3, 4, 5 doubled to 6, 8, 10. I'm going to go ahead and square everything. That's going to be 64 is equal to 100. And we're going to subtract the 64. And r squared is equal to 36. And of course, when we take the square root, we get the r equals 6, which was expected. What we're going to do next is we're going to use this idea to be able to program our cone program. And we're going to use the specialized case where we're going to do it in general. So instead of putting numbers in it, we're just going to leave it in terms of r and h and l. And we're going to solve them and put it within our program so that we don't have to do this over and over again. Okay, so hopefully that makes sense to you, and we'll come back and I'm going to show you how to program your calculator to do the cones.